Hi everyone, today we will start with chapter 3 equivalent systems of force for the subject of applied mechanics. Okay, so now we go to the slide. We start with the slide. Okay, for chapter objective, here what we're going to achieve in the end of the subject. So this chapter about the moment of a force and how we're going to calculate and show in the 2 and 3 dimensions, and also to define moment of a couple, and to find the method to determine the resultant forces on non-concurrent force system, and to indicate the simple distributed loading at a specified location to a resultant force. Okay, these are the chapter objectives. And for chapter outline, we will go one by one. So first we start with the moment of a force. It's a scalar formulation, and then cross product, and then moment of force. It's a vector formulation. Okay, first scalar formulation, and then vector formulation, and then principle of moments, and then moment of a couple, and then the system of resultant force and couples, and then finally system of distributed force. Okay, for information, this chapter will take around 3 weeks time to complete. So according to our teaching plan, so first we will cover for this week, we will cover moment of a force for scalar formulation, cross product, and moment of a force for vector formulation. Okay, these three will be covered for this week lecture. Okay, so moment of a force. Okay, for scalar formulation, moment is defined as a force above. Okay, the force about the point or axis. Okay, this is a point, this is the axis. Okay, so we axis provide a measure of tendency of the force to cause a body to rotate about the point of axis. That means the force that we applied, it's will tendency to rotate according following the axis or the point. Okay, this is called moment. And then torque is a tendency of rotation caused by fx or simple moment. Okay, the torque is tendency of rotation caused by fx or simple moment called MOZ. Okay, this is for the definition for the torque. Okay, for the magnitude, we use MO here for the moment, and MO equal to FD. Okay, F is force in Newton, D is distance in meter. Okay, so D is perpendicular distance from the direction of force. So if you see here, the D is perpendicular distance from the direction of force from O to its line of action. Okay, so O is original, from O to the line of action. Okay, and then the direction is specified by using right hand rule. Okay, so here we use right hand rule here for moment axis, and to find out the uh, value or positive negative. Okay, fingers of the right hand are curled to follow the sense of rotation when force rotate about point O. Okay, so the fingers are curled. So we curl the finger and we find out how it rotate. Okay, so here the arrow here are the sense of rotation. Okay, so if you see here, it's a counterclockwise. Okay, here we got two type of rotation. One is counterclockwise, another one is clockwise. So here is counterclockwise. Okay, resultant moment. Okay, resultant moment uh, is given by MRO. Okay, moment resultant, and is a moment of all forces or summation of all forces along the line or axis. Okay, so here the, for example, the F on, force on, acting in this direction, force 2 acting in clockwise direction, F1 in uh, counterclockwise direction, and F3 also counterclockwise direction. And here are the D that perpendicular to the line of force, here also same. And this is the moment that caused by the force and distance. Okay, moment equal to force time distance. So this is the where the place the moment occurred or generated, then it start to uh, follow the direction of the force. Okay, here counterclockwise, M2 clockwise, and M3 counterclockwise. Okay, so this is how the rotation occurs when it involves only two axes. So in this case, for scalar formulation, we only count for x and y for the calculation, and z axis become the point of rotation. Okay, so the z axis, our right hand rule, we use as a axis of rotation. Okay, so F1, F2, F3. This is another example from here. Not not the same. Okay, F1, F2, F3 here all are counterclockwise, but here different case. Okay, so the calculation, how the calculation happen. So first the distance will be given. So where we going to apply the force? Okay, let's say we apply the force at point of 2 meter from origin, and the direction is this way. Okay, this is the way direction being done. And for the second question, the this length is 2 meter, but the force is being applied here. Okay, around this area the force is being applied. So here the distance is 0.75 meter. Okay, for the calculation, MO equal to FD, F equal to 100 Newton given here, and distance is 2 meter. So the value will be 200 Newton meter clockwise. Okay, kalau if CW is a clockwise, if CCW counterclockwise. Okay, that's the difference. Okay, for here MO equal to 50 Newton. Okay, this value is given, and then the distance is 0.75 meter. Why we never take 2 meter? Because the force is being applied here. So when the force is being applied here, we just take the distance of this. Okay, let's say if the force is being applied here, like here, this case, then we will take this 2 meter. But when this case, the 15 Newton is being applied here, we just take 0.75 meter. So when we compute, we got 37.5 Newton meter. This also same clockwise direction. Okay, so again another calculation. Okay, so for the first there is 4 meter here, and then there is angle here. Okay, the cos are the 30 degrees, so the force is being applied here. Okay, 40 kilonewton. So how we going to solve? We will solve this angle to be in same axis with this 4 meter. So when we want to solve this, so it will be 2 meter times cos 30. Okay, so 2 meter times cos 30, it will be along the axis, same axis. So 4 meter plus 2 meter cos 30. So this will give you the value. uh, Cos 30 is 0.866. So times with 2, and then plus with 4, and then times with 40. Okay, so we got value of 229 Newton meter. Okay, for the force being applied here, how much the moment. And for the D, the calculation of D, the force being applied is 16 Newton outwards. Okay, the force is 16 Newton outwards, and the place that we're going to calculate is this area, okay, for just for 1 meter, and the value is 45 degrees. So we going to solve along the axis. So when we solve along the axis, 1 meter times sine 45. So 1 meter times sine 45, we got 0.7071, and then times with 60, we will got value of 42.4 Newton meter. But here it's a counterclockwise, okay, here it's a counterclockwise. So here we will write CCW, counterclockwise. Okay, this case is a bit different. The length is 4 meter, but the force is being applied after 1 meter. Okay, this part, okay, the 7 kilonewton is being applied here. So how are we going to calculate? We will minus 4 meter with this 1 meter, and then we do the calculation. Okay, so for 7 7 kilonewton, the force times with the 4 meter minus 1 meter, okay, the difference between this and this, so the 3 meter, and then we will do the calculation. So we got 21 kilonewton meter, okay, because the value is kilonewton, here also kilonewton, here also kilonewton, and then the D is meter. Here the direction is counterclockwise. Okay, so any moment the calculation, you should give the value of direction, the rotation's direction, okay, either clockwise or counterclockwise, so that you also easy to understand, and we also can know your intention to show the direction. Okay, here we're going to find the resultant moment for four forces. Okay, so if you see here, four forces are 15 Newton here, 16 Newton here, 20 Newton here, and 40 Newton here. Okay, so how much forces resultant moment that acting along the point O? Okay, so here we do the calculation by counterclockwise is positive, and clockwise is negative. Okay, the same theory that we have seen before, but calculations before this we never noticed the positive and negative because we just put counterclockwise and clockwise. But here we will start with uh, the direction. Okay, let's say the 50 Newton here, it's a negative because it's a clockwise. So if counterclockwise, it will be positive. Okay, here it will be positive. Okay, so here the calculation will be negative 50 Newton, okay, this value of force, times with 2 meter, okay, times with 2 meter here. Why negative? Because clockwise, and then plus, okay, plus because 16 Newton here is counterclockwise, this direction is counterclockwise, uh, plus 16 Newton, and this point is when you solve for the uh, y-axis, it becomes 0, and then plus 20 Newton, okay, this one 20 Newton, and for sine 30, okay, for sine 30, it involves 3 meter from here to here, okay, from here to here it involves 3 meter, and sine 30 it will become positive to here, and then minus 40 Newton, okay, again clockwise, and 3 meter cos 30, okay, this part, plus here. Okay, why here we count this 4? Because this 40 Newton force is being applied at this point, counting together all of this, okay, the 4 meter here and 3 meter cos 30 here. Okay, so that's why we count everything, and then this is the value we get. Okay, so the detailed calculation I will give in another sheet, so that easily can be understand for the calculation. So when we solve this, we will get value of negative 33.92 Newton meter or when we write 33.92 Newton meter in clockwise direction. That means it's a negative value, you can write like this, or if you write in a positive value, you write in a clockwise direction. Okay, that's how we do the calculation for this part. Okay, here the 20 Newton, that force is here. We never apply the 4 meter here because here the 20 Newton to sine 30 we solve to y-axis. Okay, that means the y-axis just take part until this part only. It won't take until this, but this 40 Newton it will take until 4 meter, and also the cos 30 along this way. Okay, along this way. Okay, this 20 Newton just involve this because it's rotate for this way. Okay, for the slide number 10, the example is given 3.1.2. So how we will write? We will do this sign is showing the moment's direction. When it counterclockwise, it's a positive. Okay, so we will write M RO and then equal to summation of force times D. Okay, so from the value given we will get negative 50 Newton times 2 meter. The initial distance from origin until the 2 meter, and then 60 Newton times with 0, because the 60 Newton when we want to times with the value start point 0, because it's a point that acting at after the 4 meter. Okay, so we can't calculate the 4 meter, we start with the 0, and then plus 20 Newton and 3 meter sine 30. Okay, and then 40 Newton 4 plus 3 meter sine cos 30. Okay, cos 30 here. Okay, why the calculation is we showing the cos 30? Because the 3 meter we want to resolve according to the x-axis, and then for the this part, the 3 meter sine 30, that one, the 20 Newton that acting on the part, we solve into 30 degrees. Okay, and then when we do the calculation, here we will got negative 100 Newton meter plus 0 plus, okay, sine 30 times 3 meter times 20. Okay, sine 30 0.5 times 3 meter 1.5 times 20. We will get 30 Newton here, 30 Newton meter. Then minus here the cos 30 0.866 times 3, we will get value of 2.598, and plus 4 6.598 and times 40. Okay, we 6.598 and we got 263.92 Newton meter. Okay, so this is the value we got here, and then from here we going to compute everything. So when we do the computation, we will get negative 100 plus 30 plus negative 263.93. Okay, so we get value of negative 333.92 Newton meter, which is when negative it's a clockwise direction, okay, or we also can write as 333.92 clockwise direction, CW. Okay, okay, cross product. Okay, cross product, understand this circle. Okay, so again the counterclockwise is positive and clockwise is negative. So if I times j, the value will be positive k. Okay, I times j positive k, and j times k positive I, and k times I positive j. Okay, so here's the value. And then for negative, okay, j times I, okay, j times I will give negative k. Then I times k will give negative j. I times k will give negative j, and then k times j. K times j will give negative I. Okay, and then I times I equal to 0, j times j 0, k times k 0. Okay, so we can use the circle for the result, this circle, and then this right hand rule to get the positive and negative. Okay, so I times j, j times k, k times n, we give the value of positive. The reverse, the reverse multiplication will give negative value, and when it times with its own self, it will give 0. Okay, 0 value. Okay, here the multiplication of the a times b, okay, in the I and j component. Okay, so axi, ayj, azk, a components in ijk terms, and then b components in ijk terms. So when times, okay, when times, axi will times with here, here and here, and then plus, okay, they plus everywhere, and then this one is ayj will times with here, here and here, azk will times with here plus here. So when we do the lengthy calculation, so here is the answer we got. So once we got this answer, we can start to uh, get in terms of this. Okay, if I times I is 0, okay, so the whole equation will be 0. I times j equal to k, and then I times k equal to uh, j. Okay, and then j times I, here the value will be negative. Okay, so when we start to do the calculation, we will get the negative value, negative j here, and then j times I negative k, and then j times j is 0, and then j times k is I. Okay, positive I, k times I is j, k times I equal to j, k times j equals to negative I, and then k times k is 0. So the 0 value will be multiplied with this, and the overall will be become 0. Here will become 0, and here will become 0. So when we take out the 0 and then we start to do the calculation again, we will get in terms of I, j and k. Okay, this one also the calculation I will give in the sheet so that you can understand better. Okay, for the calculation of cross product. Okay, for the loss of operation for cross product, we will do calculation of a times b. Okay, so here the a times b, we will give value of um, the entire a times with the b. So axi plus ayj plus azk. this value times with b, bxi byj plus bzk. Okay, so we will times both for each component. Okay, so axi times with this, axi times with byj, axi times with bzk, and then ayj times with bxi, ayj times with byj, ayj times with bzk. So everything we times and we plus. Okay, so when we times here, we will start with the I component first. So we straight away can put in a format of the value. Okay, so here ax times with bx. Okay, so I plus I. Okay, I plus I, and then plus with ax by ax plus times by, okay, times by times with I plus j. Okay, I plus j, and then plus ax times with bz, and the value will be I plus z, k. Okay, I plus k. Okay, so for I times k, I times k, here times, here times, okay, here also times. Okay, that means we are putting the value into want to solve the cross product value, so that's why we can times here. Okay, when we times, we can easy to solve or cancel each other. Okay, and then this part continues. A y times bx, so j times I, j times I plus ay times with by, so here it will be ay by j times j. Okay, then plus ay times bz, ay bz, so value will be j times k. Okay, so continue with az bx zk times I. Okay, plus az by k times j plus az bz k times k. Okay, so we're done with all the values. Okay, so now we can start to do the calculation based on our slide. Okay, and the slide we already known for the value of I times j times k, and k times I, and also I times k, j times I, and k times j, and also I times I, j times j, and k times k. So based on that value, we will start to do the maths here. So first we will see the same. Okay, I times I, it will give value of 0. Okay, and then j times j will give value of 0. That means the overall this value will become a 0 times with 0. Okay, so everything cancel, and k times k will give value of 0, and here also it will become 0. And then when I times j, okay, I times j, it will give value of k. Okay, where we take this from? Actually we take this from our slide number 11. Okay, I times j equal to k, j times k equal to I, all positive, k times I equal to j. Okay, this value, and then from here also I times k equal to negative j, j times I equal to negative k, k times j equal to negative I. Then I times I, j times j, k times k. Here all the value will give 0. Okay, how they determine this? Follow this way. Okay, k, j, I, k. If this way positive, this this way positive, this way negative. Okay, so every value that we times, okay, I times j positive, it's this way, so we got value k positive. J times k, we get value of I positive. K times I, we get value of j positive. Okay, same here, it become in a negative reverse way. Okay, so from here we compute this. Okay, we will I times j, here we get k. Okay, I times k, we got value of negative j. Okay, and then j times I, we got value of negative k. And then j times k, okay, j times k, we got value of positive I. And then k times I, we got value of positive j. Then k times j, we got negative I. Okay, so now we got value in a simpler format. So now we can start to calculate. So here the value become ax by k, and then here plus with the negative k. Okay, ax by k. So we will plus everything, then we minus with this. Okay, so from here how we going to write? Ax by k positive plus ax bz negative j plus ay bx negative k plus ay bz positive I, ay bx, here this part, positive j, and then plus az by negative I. Okay, so now we got all in this term. So now we put everything in on side. So I we take first. Okay, so when we take high here, positive high is here. Okay, this one positive, ay bz I plus az by negative I. Okay, then plus for j, ay bx positive j. Okay, we put positive here first, and then plus ax bz negative j. Okay, then plus for k, ax by positive k, and then plus ay bx negative k. Okay, so now we write until here already. So we take this to here. Okay, this part. Okay, so ay bz I minus az by I. Okay, because this negative here we already changed to positive. Okay, then plus ay bz bx positive j minus ax bz j. Okay, plus ax by k minus ay bx k. Okay, so now all we put in I and j terms, and we convert the positive negative here already. Okay, so now we take out the I and j's. Okay, so it will become ay bz minus az by. Okay, here and here we take out the I, so I we put here. Okay, or I we just put without the bracket also, acceptable, plus ay bx minus ax bz. Okay, j plus ax by minus ay bx k. Okay, so now we already put in the this format, which we can do the calculation. Okay, so for the cross product we can use the matrix form. Okay, so ijk and ax ay az and bx by bz. Okay, and then when we times, okay, when involves I, we won't take these elements. Okay, when involves I, this line will be blackened. So ay times bz minus az minus az times by, ayz times bz minus az times by. Okay, for value of I, and for the value of j, okay, j, it will give you value of negative here. Why negative? According to our calculation slide before, the negative here will be negative, the value of j will be negative. Okay, when we write down, so when j we cross this line and here, so when we cross here and here, ax times bz minus az times bx. Okay, and then the last one is for k, so k we hide this part, so ax times by minus ay times bx. Okay, this is how the calculation for the cross product.